The history of architecture in New York begins with its early colonial buildings that shaped the city's original identity. Over time, the development of steel frame construction opened the door to vertical expansion. This innovation gave rise to iconic skyscrapers that defined New York's silhouette. Architects began experimenting with height, design, and structural creativity. New York quickly became a global symbol of architectural ambition and modernity. Each new tower pushed engineering boundaries and influenced urban planning. The Skyline became a representation of human determination and technological growth. Architectural achievements reflected cultural, economic, and artistic changes. New York's buildings evolved from simple structures to masterpieces of engineering. This evolution laid the foundation for architecture that would eventually influence aviation design. As skyscrapers rose higher, architects relied heavily on improved materials and stronger foundations. This led to the use of reinforced steel and advanced load-bearing technologies. Every building required precision, calculation, and a clear understanding of physics. The same principles soon migrated into engineering fields beyond architecture. Innovators realized that lightweight structures could achieve extraordinary stability. This discovery became a bridge between skyscraper technology and aircraft innovation. The idea of balancing weight and strength became central to both fields. Designers learned how to manage stress, wind load, and aerodynamic forces. These shared principles connected the evolution of buildings to flying machines. Thus, architecture played an unexpected role in shaping early aviation thinking. New York's architectural development also led to advances in wind tunnel studies. Tall buildings needed research on how wind interacted with vertical surfaces. These studies helped engineers understand turbulence and air pressure patterns. This same research became essential for early aircraft wing designs. Architects and aviators both learned from the behavior of airflow around structures. The collaboration of these fields improved aerodynamic performance in aviation. Wind science became crucial for modern design in both cities and skies. Techniques for reducing drag were later applied to high-performance aircraft. Architectural knowledge provided a scientific advantage for aircraft shaping. This connection revealed how deeply architecture influenced aviation engineering. The introduction of Art Deco architecture brought curves, symmetry, and streamlined designs. This aesthetic style soon found relevance in the design of early aircraft bodies. Streamlined forms created less resistance and improved mobility. Aircraft manufacturers studied building silhouettes for performance inspiration. The relationship between artistic design and aerodynamic function grew stronger. Architects and engineers collaborated to refine shapes that blended beauty and utility. The Chrysler Building became an example of elegant streamlining in architecture. Its influence on sleek aircraft contours became widely recognized. Design harmony unified both fields through a shared appreciation of efficiency. This era highlighted how artistic architecture guided the evolution of aircraft forms. When jet technology emerged, it brought a new chapter in design thinking. Aircraft required materials that were stronger, lighter, and more heat-resistant. Architectural engineers followed this development and adopted similar materials. Titanium, aluminum alloys, and composites became essential in both industries. New York's new generation of towers used these advanced materials for stability. The aircraft industry showed how lightweight strength could transform construction. Material science became the link that connected sky and skyline. Stronger composites made taller, safer buildings possible. Advanced alloys made faster, more efficient aircraft achievable. Both industries pushed boundaries with the same innovative materials. Aviation also influenced the future of city layouts and architectural planning. A need for airports reshaped the outer regions of New York. Runways demanded large open areas and strategic airspace design. Architects developed terminals that blended functionality with cultural expression. Airports became modern gateways symbolizing global connection. These structures required careful planning similar to skyscraper complexes. Passenger flow, safety standards, and aerodynamic needs guided every design. The architecture of airports evolved into sophisticated engineering marvels. Their scale and complexity matched that of major urban structures. Aviation and architecture grew together in shaping modern cities. The rise of modern technology introduced smart materials into both industries. Architects used self-healing concrete, adaptive glass, and robotic construction tools. Aircraft manufacturers implemented responsive surfaces and intelligent wings. Both fields embraced automation and digital simulation for precision. Computer-aided design transformed how structures and aircraft were conceptualized. Digital modeling allowed engineers to test ideas without physical prototypes. This reduced cost, improved accuracy, and accelerated innovation. Virtual wind analysis improved aerodynamic and structural efficiency. Technology became the ultimate connection between buildings, and a digital evolution unified architecture and aviation into a shared future. New York's architectural influence expanded through global trends in aviation spaces. Iconic terminals inspired airport designs in cities worldwide. These terminals served as cultural statements, just like skyscrapers. Architectural masterpieces became symbols of national progress. Countries used aviation architecture to highlight modern identity. Designers studied New York's approach to blending art and engineering. This knowledge enhanced international airport aesthetics and performance. Terminal design became an extension of urban creativity. Aviation architecture evolved with global artistic exchange. Buildings and aircraft shared a unified design philosophy. As aircraft technology advanced, architects studied cockpit layouts for efficiency. This inspired smart building control centers and automated monitoring systems. The interaction between humans and machines guided city infrastructure designs. Skyscrapers introduced integrated digital command rooms like aircraft cockpits. These systems improved safety, performance, and energy control. Architectural engineering adopted aviation-style precision for critical operations. Both fields shared a commitment to advanced technology and user safety. Human-centered design became a priority for both pilots and building users. Innovation merged the disciplines into a synchronized technological ecosystem. Aviation inspired architecture towards smarter and safer environments. Sustainability reshaped both industries in the 21st century. Architects designed eco-friendly buildings with renewable energy systems. Aviation engineers developed fuel-efficient aircraft with reduced emissions. Both fields aimed to minimize their environmental footprint. Green roofs and solar-integrated skins became part of urban towers. Aircraft adopted lighter materials and optimized aerodynamics for efficiency. Environmental awareness transformed design goals in both industries. Sustainability became a core priority for future technologies. Architecture and aviation aligned toward a greener world. This shared mission redefined the direction of innovation. The cultural symbolism of skyscrapers and aircraft also connects their histories. Skyscrapers represent ambition, achievement, and human progress. Aircraft symbolize freedom, exploration, and global unity. Both capture the human desire to rise above limitations. New York's skyline reflects this spirit with every towering structure. Aircraft reflect it with every journey across the sky. Together, they embody aspiration and technological mastery. Architecture shapes the earth, and aircraft shape the skies. Both transform the world through creativity and innovation. Their stories continue to evolve together. The globalization of travel increased demand for advanced airport architecture. New York's airports expanded with modern terminals and runways. Architects designed multifunctional spaces for millions of passengers. Aviation technology enabled faster, safer global travel. This required terminals that could manage high capacity with elegance. Architectural innovation ensured comfort and efficiency in airport design. The link between air travel and architectural planning became essential. Both fields supported global trade, tourism, and cultural exchange. Cities grew around airports as new economic hubs. Architecture and aviation shaped modern connectivity. The influence of New York's engineering success inspired futuristic aircraft concepts. Designers studied skyscraper stability to enhance aircraft structures. Both industries experimented with flexible materials and dynamic load management. The fusion of knowledge created aircraft capable of extreme performance. Concept aircraft adopted architectural principles for balance and endurance. These innovations shaped long-range military and commercial aviation. The shared design language improved safety and functionality. Architecture provided structural wisdom for futuristic aviation ideas. Aviation returned the favor through aerodynamic understanding. Both domains progressed through mutual inspiration. Architectural megaprojects redefined urban skylines and influenced aviation hubs. Complex tower designs required careful study of structural vibrations. Aircraft designers used this research to improve wing vibration control. Both fields used computer simulations to analyze stress distribution. Advances in modeling created stronger, safer designs. Giant towers and long-range jets shared engineering challenges. Structural integrity became a shared scientific objective. Knowledge transfer improved both skyscraper and aircraft reliability. This strengthened the partnership between the two industries. Collaboration unlocked a new era of scientific synergy. The story of architecture from New York to aircraft represents human innovation. Both fields evolved through shared principles and technological exchange. They advanced together from steel-frame skyscrapers to supersonic jets. Every breakthrough in one field inspired progress in the other. The connection between buildings and aircraft formed a circle of evolution. This circle continues to grow with new scientific discoveries. Architecture reaches upward and aviation reaches outward. Both shape the world through ingenuity and imagination. Their shared history reflects human ambition without boundaries. This journey continues as the future of architecture meets the future of flight.